In this video, I'm going to talk about average rate of change and instantaneous rate of change. First, I'm going to talk about average rate of change. An average rate of change should be a familiar concept. It's what we usually call the slope. So our formula is going to be, I'm going to abbreviate it as AROC, average rate of change. The function of b minus the function of a over b minus a. Or, to make it a little simpler, it's just the change in y, delta y, over the change in x, delta x. And this is probably the one you've seen before. That just means that when you have a line, you have your 4 points in when you graph it. So let's say you have something like this, and your line was like this. You'd have, let's say, a point here, and a point here, and then the same in the x-axis. You have a point here, and let me put it as green, a point here, and you would just plug the points into this equation, and you would get the slope of the line. So that's just our average rate of change. But what we really care about is what we call instantaneous rate of change, and that's, in other words, a derivative, which you will use vastly in calculus. So let me write it down. This is a derivative. However, when we're talking about instantaneous rate of change, we have to introduce limits. So using our average rate of change equation and limits, you can just obtain your instantaneous rate of change equation. I'll abbreviate it as IROC. That's going to be the limit when h goes to 0. Our equation is f, the function of x plus h, minus the function of x over h. So that's the instantaneous rate of change, or the derivative. So you can just erase this and write it as how a derivative is usually written. That will be f prime of x. So the derivative function of fx is going to be f prime of x. And I'll do a quick problem using this equation to show you how it works. So let's say that our function is going to be equal to x, so fx is equal to x, and we want the derivative, so f prime is what we're looking for. Now let me write the equation real quickly so you can picture it, how I plug in the values. So the limit when h goes to 0, it's f x plus h minus the function of x over h. So this is our equation. And now plugging in the data they gave us, you can say that f prime of x, or the derivative of the function of x, is going to be the limit when h goes to 0. So they say that the function of x is equal to x, and we have here that we want the function of x plus h, so that's just going to be x plus h, and then simply the function of x is equal to x, so that's going to be minus, let me put a parenthesis here, minus x over the h we had before. So this x will cancel this x, and we will have that h, let me write it down because it doesn't fit. So the f prime of x, when the limit of h goes to 0, it's going to be h over h, so that's just going to be 1. And that's why the derivative of x when it's with respect to x is going to be 1. And I will do multiple problems in the following video to help you understand instantaneous rate of change better, because it's a pretty essential concept. And well, that's it. If you found the video helpful, like it and share it with your friends.